we're going to all right, just somewhere in your notes here, we're going to do a little bit of trig, a quick review of last year here in about 15 minutes. Okay? All right, now this first part, I don't know if there's anything you necessarily need to write down, but as when you first started learning about angles as radian measure, okay? Okay? Radian measure is really quite simple in the sense that it is simply the length of that red arc. Radian measure is simply just a number and that is a length, as opposed to degrees. Degrees is kind of this made-up unit that comes from the fact it took 365 days for the Earth to go around the sun, which it doesn't even go in a circle. It's an ellipse, but and then they round it down to 360. It's fairly arbitrary what a degree is, and it comes from that whole stuff there. And it's pretty useful for geometry and things like that. Okay, but when it comes to graphs of trig functions, when it comes to calculus and higher level stuff, degrees makes things much, much more complicated. The formulas are crazy complicated, but radians are much easier. Now, one of the formulas that you had last year was S equals R theta. Okay, the arc length of a circle, if you're in radian measure, is simply the radius length times the radian angle. So this arc length is simply the radius times the angle. Well, why do we use the unit circle? Because it has a radius of 1. And that makes it even easier yet. Okay, because the trig ratios are the same no matter how big the circle is, just like with the triangle. If we think of SOHCAHTOA, if I draw a 40-degree angle in here, and the sine would be this side A over this side C, it doesn't matter if I make a bigger angle. Okay, if I make a bigger triangle, and this is capital A and this is capital C, the ratio of A over C is going to be the same as the ratio of big A over big C, right? They're going to be in the same ratio. So it doesn't matter how big this hypotenuse is. So we might as well make it easy on ourselves and let the radius be 1. In that case, the arc length is the angle. Okay? So the red arc length is the radian angle. And then the word radian comes from radius. Okay? So now it's making sense, okay? So now, when you go around the circle here, okay, all the way around, whoops, very good at that. Oh, I missed it. All right. We'll do this.
You do theta slowly.
There we go. All right. When we go all the way around the egg, as we go all the way around the circle, what's the circumference of a circle?
That circle or
A circle. 2 pi r, right? That's the circumference. But in our circle, not that circle, but in the unit circle, since the radius is 1, the circumference is 2 pi. So we just got done saying that the radian measure is the length of the arc. If we go around the circle, then the arc is the whole circumference. And so that's why we say 360 degrees is 2 pi, because it's the circumference around the unit circle. That wouldn't be true in a bigger circle, that the circumference would be 2 pi. Okay, but remember the original formula I had up here. I had S equals R theta. Okay, so if So theta is technically s, the arc length, divided by the radius. So if I took 2 pi r, the arc length of a full circle, right, divided by r, you can see it doesn't matter. So it doesn't matter how big the circle is, it's still 2 pi radians around it. So again, that's where the 2 pi comes from, because it's just the length around the circle. All right, and so that's why half a circle is pi, and a fourth of a circle is pi halves, and so forth. Okay, so that's radian measure in a nutshell, where that comes from. All right, then, of course, we had the right triangle stuff, the SOHCAHTOA, and that comes in handy here, right? That sine is, remembering that sine of an angle is the opposite leg over the hypotenuse, the cosine is the adjacent over the hypotenuse, and the tangent is the opposite over the adjacent. That comes in handy in certain problems. And especially if you haven't memorized the unit circle, then you're gonna use that a lot. Okay? So there's that. And then finally the unit circle. And these are the things that we really need to know. Okay? So let's start on the unit circle here at 30 degrees. Now if you wanted to write this down, you certainly could, because especially if you don't have them memorized. Okay? But on the unit circle here, we have sine of 30 equals 60 degrees. Or excuse me, the sine of 30 is the y value. So this up here is the sine. Okay, so the y value is the sine, and the x value is the cosine in the unit circle of the point around it. Because again, since cosine is adjacent over hypotenuse, it would be this x value over the radius, which is 1. So the cosine is just the x value. The sine is the opposite, which is the y value, over the hypotenuse, which is 1. So y over 1 is just y. So sine is the y coordinate, cosine is the x coordinate. So just remember, sine rhymes with y. Sine is the y coordinate. So when we ask when is sine positive, well, it's positive in these two quadrants, because that's where the y's are positive. Okay, whereas sine negative is down here where y is negative. Same thing with cosine. Cosine's positive in 1 and 4, because that's where x is positive. Cosine is negative in 2 and 3, which is where x is negative. Okay? Now, if you haven't memorized those values of square root of 3 over 2 and 1/2 and so forth, then you'll have to memorize this. Okay? You'll have to memorize that a 30-60 triangle. Now for us, we won't write 30, we'll write pi 6, and a 60 is pi thirds. Because remember, pi is like 180, right? That's the conversion you always want to remember. That pi is equal to 180 degrees. As long as you know that, it's an easy substitution. 180 divided by 6 is 30. 180 divided by 3 is 60. Okay? But in a 30-60 triangle, the relationship they have is 1 here, 2 on the hypotenuse, square root of 3 there. Now I know in Mrs. Payne's class she wrote that differently, right? Because in Mrs. Payne's class she was always going on the unit circle. So she would write 1 on the hypotenuse. That show up red? Cool. She would write 1/2 over here, and she would write square root of 3 over 2 here. Right? And that's what they are. But in your other trig classes, you may not have written it that way. And in geometry, I know in algebra too, when you work with SOHCAHTOA, you usually write it the way it is in the black. Okay? Either way is fine. So now if I ask for the sine of pi 6, and you don't have that memorized, then what you want to do is say, okay, that's 30 degrees. Drawing your triangle. 1, 2, square root of 3. Sine is opposite over hypotenuse. 1/2. You need to be able to get those values without a calculator. Not for tomorrow's quiz, but down the road, anytime there's a no calculator quiz, and there's something that asks about sine of pi 6, you got to know that's 1/2. If that means you have to draw yourself a little picture of a 30-degree triangle, then that's fine. Go ahead and do that and use SOHCAHTOA. All right? tangent would be 1 over square root of 3. And I'm okay with you leaving it that way. If you do tangent of pi 6 and you leave it 1 over square root of 3, that's fine. Okay? All right. The other triangle you need then, and yell at me, Seth, if I'm standing here or whatever. Or should I yell at him? Yell at me if I'm standing in your way. Okay. Pi force, okay, at 45, root 2 over 2. That's because in a 45 triangle, it's isosceles, and so these two sides are the same. Now, if you're not, that's the other triangle you'll have to remember. Okay? So a 45, which for us is pi force. Okay? Geometry class, algebra class, they would usually write it like that, probably. 1 square root of 2. Mrs. Payne writes it square root of 2 over 2, square root of 2 over 2, and then 1. Okay? Didn't go. Okay? All right. So, again, you'll have to memorize that triangle and its relationships. So if we ask for the cosine of pi force, draw yourself a picture. It's in the first quadrant. 1 square root of 2. Cosine is adjacent over hypotenuse. 1 over square root of 2. It's okay to leave it like that. That's also square root of 2 over 2. Same thing. Okay? So again, we have the 30, the 60, the 45, the pi 6, pi force, pi thirds. We have to be able to write those. All right. Then when we get into, okay, the next quadrant, and I'll leave the 90 for another time. Okay, so now we get over here to 2 pi thirds. Okay, now, hopefully you've got that memorized. You know, if you have it, you know what quadrant you're in. You know, pi thirds, know what that would be as degrees, know what the reference angle is, those kind of things. If you don't have that memorized and you're asked to do okay, if you're asked to do sine of 2 pi thirds, all right, Harry, what's my
Huh?
Did I call you?
I kind of see you for a second
Yeah, just let me know. That's a good way to do it. There's also the raising your hand and say, "Hey, I can't see." That'll work too.
there. We like to mix it up in this class.
Yeah, that's true. We don't want to get stale. All right, sine of 2 pi thirds. You can convert that to degrees if that helps you. So 2 times 180 would be 360. Divided by 3 is 120. So 120 degrees would be over here. Okay, which would leave you 60, and that's the key. And last year in Trig, we called that a reference angle. So it's a 60-degree reference angle, which would be pi thirds. And you know that across from the 60 is root 3, on the hypotenuse is 2, and down here is 1. Okay, so you have to know, again, you have to know those relationships. Now, the difference, though, is that's negative, because you're over that, going that way. Okay? So sine would be opposite over hypotenuse, so we wouldn't need the, because sine is positive over there, because the y's are positive over there. But there's sine of 2 pi thirds. So if you don't have memorized, draw that triangle and go from there. Okay? Square root of 3 over 2. All right, back to the picture. So you can see there's sine, the y-coordinate is square root of 3 over 2. The cosine, the x-coordinate is negative 1/2. And we keep going. We keep going along there. If we get over into the third quadrant, 7 pi 6, okay, again, 7 pi 6. Another thing that is important, I think, are these fractions. Okay, how do you know where 7 pi 6 is? Well, if you've got 7 pi 6, that's clearly more than 1, because you've got 7 over 6, right? So that's a little more than 1 pi, so it's got to be more than 180. It's how much more? It's 1 pi 6 more, okay? So you'd have a pi 6 reference angle here, and you could label your triangle. Now, both are negative this time. Okay? This is negative root 3 this way. This is negative 1 down this way. This would be 2 if you're labeling them that way. Okay? So notice cosine and sine are both negative there. Okay? So being able to draw these triangles in their quadrant where they're at. Now, the last part of this would be what happens if you're right at 90. Okay? So what happens if you're asked to do cosine, or let's do sine first. If you're asked to do sine of pi halves, what is that? One way to do it is the unit circle. So you ask yourself, okay, on the unit circle, it's straight up. There's no triangle to draw, so this stuff doesn't work, right? SOHCAHTOA doesn't work because there's no triangle. So at 90, you have to remember that cosine is the x and sine is the y. So at 90, you're straight up. The y would be 1, that's sine, and the cosine would be 0. So sine would be 1, cosine of pi halves would be 0. Of course, tangent would be sine over cosine, which would be, in this case, undefined. Okay? Now, another way, though. Again, some people don't like the unit circle. They're not crazy about the unit circle. And I'll be honest, this is the first thing I think of when I see sine of pi halves, I'll be honest, is not the unit circle. Is I think of a quick graph of sine and cosine. So if I'm going to do sine of pi halves, and so if you don't like the unit circle, I think this will be pretty handy. Make yourself a quick graph of the sine graph. Where's pi halves? Right there. So sine of pi halves is 1. And you want to do cosine of pi halves, make a quick graph of the cosine graph. Where's pi halves on the cosine graph? Right there, at 0. Okay? So anytime you have the pi halves, the 3 pi halves, the pi, the 2 pi, those ones that land right on a quadrant, right on an axis, make a quick little graph of those. So you get your 1, your 0, your negative 1, that kind of stuff. 3 pi halves, or for pi, cosine is negative 1. Well, yeah, that's this point over here. Cosine of pi. 3 pi halves at 0 again. Sine of 3 pi halves is down here at negative 1. That's true, because 3 pi halves is sine, the y value is down here at negative 1. Okay? So either use the unit circle or use a quick sine or cosine graph. Okay. Let's see, last thing here, some of this in action. So let's solve a trig equation. This is where this is going to come in most handy. Oops.
Hey.
So solve this equation.
Didn't you hear him?
Fifth?
Okay, solve that equation right there. No calculator. Little hint for those of you that forgot algebra. 2 things multiplied equals 0. One of them has to be 0, right? So either sine x minus 1 equals 0 or 2 cosine x minus radical 3 equals 0, right? That's your start. Oh, and by the way, we're saying to solve this equation between 0 and 2 pi. Okay, between 0 and 2 pi. Okay, how many answers we got? Micah,
What?
how many answers you got?
How many answers do I have?
Yeah,
What?
3 solutions.
I only did one.
You got 1? Tori, how many you got? 3. What's one of them? Pi over 2? Pi over 2. Okay, what's another one?
7 pi over 6.
Close, wrong quadrant.
Dang pi over 6.
I don't think it's 5 pi over 6 either. Pi over 6 and 11 pi over 6. So pi over 2, pi over 6, and 11 pi over 6 are 3 solutions. Okay? So let's run through that. Okay, so first of all, we set each of them equal to 0. We get the trig equation by itself. So now we're asking the question, just like we were asking a minute ago, where does sine x equal 1? Well, you could use the unit circle. So it equals 1 at pi halves, or you could draw a quick sine graph. Okay, so I drew a quick sine graph here. It's 1 right there, pi halves. Where does cosine x equal square root of 3 over 2? What I did is I drew the triangles like this. Okay, cosine is positive in the first and fourth quadrants, because that's where the adjacent leg would be positive. The opposite leg would be 1 in that quadrant, negative 1 there, but we don't need it because we're doing cosine, so it's adjacent over hypotenuse. So across from the 1 is always the 30 degrees, so this angle here is pi 6. So this one would be pi 6. Now how do you know that? Well, 2 pi would be 12 pi 6, right? That's 2 pi. Well, we're 1 pi 6 short of that when we go around like that. So 1 pi 6 off of 12 pi 6 would be 11 pi 6. So pi 6 and 11 pi 6. Now, on your homework, there's going to be 2 sets of these equations. There's going to be some where you have to find the answers between 0 and 2 pi, which we just did. But there's also going to be some questions that say find all the solutions. Well, that's where that n pi stuff comes in. So like here at pi halves, well, you could go up to pi halves, that's one solution. Then you could go around the circle again and keep getting that every 2 pi. So you would, in that case, your answer would be pi halves plus 2 pi n. And the n could be negative, so it could go the other way too. So you could have pi halves, you could have negative 3 pi halves, you could subtract 2 pi. Okay, on this one you have to have 2 separate answers. For pi 6, and then you could go all the way around again, and all the way around again. You could keep going around 2 pi. So you'd have pi 6 plus 2 pi n, and you would have 11 pi 6 plus 2 pi n. Now, it doesn't always add on 2 pi n. Sometimes you get a first and a third quadrant solution, and they're pi units apart. You can just do it, you can just write it one time. Okay? So, depending on how the question's asked, you've got that. Okay. So, for tomorrow, You got about 20, 25 minutes here to work on this. There's 8 trig equations to solve. And then in Appendix F, I'm going to shorten Appendix F just a little bit. If you get out your assignment sheet there. Okay.
Hey. Hello.
On your assignment sheet, Appendix F, we're going to do, instead of what it says there, we're going to do 17 through 34. Okay? Now, again, on Appendix F, those are all no calculator problems. So when it says sine of pi thirds, you need to find that, you need to practice that without a calculator. Now, okay, so if you have to draw a triangle, draw a triangle. You know, if you haven't memorized, you haven't memorized. Okay? Which is fine. So it's not like you have to show work, because some of you do have those memorized. But this is the one time we will go back and review these trig values without a calculator. From here on out, it'll just be assumed that you know. And if you don't, and you're still having trouble in the homework, come in and see me so we can talk about it. Okay? So, the worksheet, problems 1 through 8 down there at the bottom, they have a couple of exercises worked out for you, give you a little help. Some are easier than others. Do 1 through 8 on the worksheet. Appendix F. Okay, go ahead and go to work.
Hey, stop